Alright, here we have a fairly standard friction problem. Okay, we've got a 10 kilogram block being pulled along a, I don't know, whatever you want to call surface. Okay? Now it's being pulled at an angle 30 degrees above the horizontal with 30 newtons of force. Now in this case, we have an object that is sliding with no acceleration. So first of all, it means we're dealing with kinetic friction. Let's get out of the way. We've got a moving object, it's sliding, so it's kinetic friction. Okay, the second thing is it has no acceleration. So what does that tell us? It tells us the net force is 0. Okay? But we still have to deal with things like, still have to split into parallel and perpendicular directions. So we got parallel and perpendicular. Okay? On the parallel, we know that A equals 0. That means we know that F net equals 0. And we also know that F net is equal to, okay, F pull minus F friction. Furthermore, we know that F pull is equal to 30 times cosine of 30 degrees. And finally, we know that F friction is equal to mu times F normal. So, we want to find mu. Now to find mu, we got to know either F normal or F friction. Okay, we actually have to know both. Sorry, we have to know both. Okay, force of friction we can find just from here. This comes out to be 0 equals 30 cosine 30 minus F friction, and we get F friction to be, oh God knows, I don't know what I did there. Excuse me for one moment. Solved it slightly differently on my paper. It's cool. Cosine of 30. $26. Okay, 26 newtons. Alright? What we don't know is we don't know F normal. Now, F normal is going to be part of the perpendicular. Okay? But again, we know perpendicular acceleration is going to be 0. We know that F net, therefore, is going to be 0. Now, in this case, we have three components to the perpendicular force. We have Fg, we have the force, the vertical force of the pull, and we have the normal force. Okay? Fg is going to be negative 9.8 times 10. F pull vertical is going to be 30 sine 30, and that's plus Fn. Okay? So we have 0 equals negative 98 plus 15 plus Fn, and we get Fn is equal to 83 newtons. Now that we know that, we can plug it back into our frictional force side, and we have 26 equals mu times 83, and we should get mu is equal to 0.313. And that is the value of kinetic friction, I should put mu k, I really should, that would take for this scenario to have no acceleration while sliding. Alright, that's it.